United States and Chinese developers are currently locked in a high-stakes race for a technology that exists far outside the public's experience with consumer chatbots. The focus of this competition is what happens when a machine learns to rewrite its own source code without human intervention. This threshold is known as recursive self-improvement, or RSI. While traditional artificial intelligence relies on humans to gather, clean, and input data, RSI allows the system to function autonomously. This graph illustrates the shift. The linear path represents traditional AI, limited by the speed at which human engineers can work. The steep curve represents self-improving AI, a system that redesigns its own internal architecture to increase its learning speed exponentially. Reaching this point marks the end of human-led software development. From there, the machine controls its own evolution. Although the technology is modern, the theoretical framework for this cycle is over 6 decades old. In 1965, British mathematician Jack Good described this process as an intelligence explosion. He envisioned a runaway cycle where an intelligent machine builds a smarter version of itself, which then builds an even smarter version, repeating the process at a pace humans cannot match. This tipping point is the ultimate geopolitical prize, as the first nation to cross it gains a permanent lead over its competitors. The United States currently holds the lead, leveraging the heavy concentration of capital and engineering talent in Silicon Valley. Anthropic, the developer of the Claude AI, recently released a new model called Mythos. Anthropic researchers state that Mythos is now edging closer to achieving recursive self-improvement. Citing the risks of losing control over such a system, the company has called for the option to temporarily pause global AI development. However, in China, leading AI companies are moving in the opposite direction, making self-evolution a state-backed priority. At the Zhongguancun Forum in March, major Chinese policymakers and investors met to discuss the immediate path toward these autonomous systems. Luo Fuli, the lead developer of Xiaomi's MiMo model, told the forum that they have already identified an actionable path to achieve model self-evolution. The internal American debate over pausing development faces a significant challenge as China aggressively accelerates its own efforts. Despite these advances in software theory, both nations face the same physical constraint. The immediate limit is compute power, which depends entirely on the supply of advanced semiconductor chips. Reaching RSI requires a continuous cycle. Data feeds into compute clusters to train a model, which creates a smarter AI to process data more efficiently. Because this demands massive physical processing power, the global chip shortage creates a bottleneck, slowing the runaway intelligence explosion. Consequently, the nation that secures the physical supply chain for microchips will largely control the timeline for achieving self-improving tech. If a self-improving system is successfully triggered, it will create immediate and diverging consequences. In a positive scenario, such a system could solve engineering and drug discovery problems in days that would otherwise take human researchers decades. The risk, however, is the alignment problem, the possibility that a rapidly self-modifying AI subverts its human-coded constraints and acts against the interests of its creators. This creates a paradox where the same tool capable of solving human challenges could also remove human agency from the decision-making process. This potential for total autonomy is what has turned the competition between the US and China into a race for survival. The winner of this race stands to gain absolute economic leadership and military supremacy that cannot be challenged by conventional means. That nation will be in a position to set the global standards for how this technology is deployed across every sector of society. The nation that falls behind faces an unassailable lead, as they will be forced to compete using traditional methods against a system that evolves faster than any human workforce. This race will determine whether the next generation of technological progress is driven by human engineers or by a machine that has taken over its own research and development.